in fracture fixation. There are a variety of ways these plates can be used. This video looks at using a DCP in compression mode. Compression mode is utilised where we want to achieve axial compression across a transverse fracture. In other words, where we want to squeeze the fracture fragments together in line with the long axis of the bone to achieve primary bone healing. The function of the DCP is based on the unique sloping oval design of the plate holes. Specific equipment is required for using a DCP in this way, and all equipment must be appropriate for the size of implants being used. A pilot drill, a load-neutral drill guide or a universal drill guide, a depth gauge, bending levers, a screwdriver, a tap device if using non-self-tapping screws. Other videos in this series have described the use of the drill guides, the depth gauge, and the bending levers. All soft tissue and periosteum must be removed from the bone surface prior to placement of the plate, and the DCP must be pre-contoured to match the contours of the bone. The plate must also be pre-stressed, which places a very subtle gap between the plate and the bone directly over the fracture. This ensures that when the screws are tightened, the far cortex of the bone is in contact. This in turn ensures that the plate is placed in tension mode. For the most practical way to apply a DCP in compression mode, the first pilot hole is drilled in the neutral position in the hole nearest the fracture on one side of the fracture line. The depth of the hole is measured using the depth gauge. A screw of the appropriate length is inserted into the hole and tightened. This video shows self-tapping screws being used, so the pilot hole is not pre-tapped. The plate is now secured to one end of the bone. The pilot hole for the second screw is drilled in the loaded position in the hole nearest the fracture on the opposite side from the first screw. As this screw is tightened, the screw head slides down the slope of the oval plate hole, travelling towards the centre of the plate. Because the screw thread is engaging the bone as the screw head moves, it causes the bone to move towards the centre of the plate and towards the other bone fragment. Assuming the bone fragments were in contact, this creates axial compression across the fracture. A further compression screw may be applied on both sides of the fracture if necessary, but it is very unusual to need more than 2 compression movements. The first screw should be loosened half a turn, as the subsequent compression screw on the same side of the bone is tightened, to allow the bone to move. This screw must then be retightened once the compression screw is in place. The remaining screws are placed in the neutral position, meaning that the pilot hole is drilled in the centre of the oval plate hole, not in the offset position. These neutrally placed screws secure the plate to the bone, but do not contribute to the axial compression effect.